MestreCast, analytical chemistry software in a fast-changing world with Santi Dominguez.
Hello everyone and welcome to a new episode of MestreCast. Today we're talking about automation with Dr. John Hollerton, who has a very long history, and I'm not going to ask John how long it is. You're of course welcome to tell us. Of developing automation systems in the pharmaceutical discovery and development areas. And I know for sure that I've been talking to you about this for a number of years. I learned a lot from visiting the GSK sites you were working at and listening to your ideas. And you know, something which I think maybe sets you apart a little bit is the fact that you have designed and implemented systems to support the generation, capture, and the analysis of analytical data. So analytical data is very much in focus for you as it is for us as a company. And as a result of this, let's say that I had my eye on you for a very long time, and finally we came together when you joined Mestrelab a year ago. And it's great to have your insights, especially from a customer or an industry perspective, being incorporated into the Mestrelab products. So, you know, with that little bit of an intro, the obvious first question, and I said, I wouldn't ask how long you've been working on it, but maybe how long have you been interested in automation and why it's a word brought it about in the first place is maybe a good place to start.
That is a good one. So I think Gary Sharman summed up this pretty well in his podcast. Using the Bill Gates quote about choosing a lazy person to do a hard job because a lazy person will find an easy way to do it. I am that lazy person, and I do find an easy way to do hard tasks. So I hate doing repetitive tasks. And when I first joined Glaxo, I was given the worst, most repetitive task ever, which was running UV spectra and calculating, extinction coefficients and lambda max. And it was all done on paper with pencil and ruler,
and yes, yeah. Those were the days. I must want to say I remember them as well, which is probably the reason why I have got a bit of grey hair on the sides of my head.
But it was a very tedious thing. It took a long time to do, and obviously there was lots of room for error as well. You mismeasure something, or you get a decimal place in the wrong place, and all of a sudden you've got meaningless data. So it had to be checked and all that sort of thing. So what I managed to do was persuade someone to buy what was a relatively new diode array UV spectrophotometer. I connected it up to a computer, and I got the computer to do all the calculations, do all the measurements for me, and then create a report which could then go back to the chemist with everything correct. You knew it was correct because the computer ran that same process time and time again. And that was my first introduction to it. And I suppose when we look at what companies are doing these days, they're looking about digital transformation. Well, the base of digital transformation is digitization, and that's what we did back in the 80s. So it's taken us a long time to get to digital transformation, but that was maybe the first step along the way.
Yeah, and I guess, you actually mentioned something interesting, which is the impact that a human error can have on some of these processes as well, which is, I think, another very interesting aspect of this, as well as the speed and productivity and the not being so bored doing repetitive tasks. But, that error avoiding, I think, is also important. Digitization is obviously a very topical subject, but maybe staying on that initial project still for a minute, and maybe just one comment on something else you said as well, which is coming from the different industries, quite shocking to see how little digitized and automated we are compared to some other industries, right? But you guys started in the 80s. I didn't realize there were computers then. But would you say that first project was a success then? Was it perceived as a success in GSK and Glaxo at the time, and especially by you?
Oh, well, technically, yeah, it worked very, very efficiently, and it cut out all the manual steps. But I think it taught me a bigger lesson in that 2 years after creating the system, we stopped doing routine UV analysis. So, you then start saying, well, was it worth spending all that time and effort doing this when we were going to ditch it some way down the line? So I think that one of the things you should think about maybe is, should I be automating this? Let's reevaluate whether this process adds value. And if it does add value, how am I going to change the process so it's more appropriate to automation. So I think my big lesson was maybe take a step back, don't rush headlong into it, think about what you're trying to get out of it and whether it's still valid.
Okay, and I think, yeah, in fact, this Gary, I think, referred to that as well a little bit in the podcast, which is there are many things that you can automate, but not all of them are worth automating, right? And certainly that reflection is important before you set off in doing a project that may not deliver enough value for the effort that you're going to make. And maybe thinking a little bit along those lines, and why do we automate, and is the effort worth it? And maybe the obvious question is, specifically in the analytical laboratories, which is our area of interest, what drives automation there? Why is automation so important? Why is it so topical? What are the drivers that bring it about and make it very relevant?
Yeah, I mean it's an interesting point. When we started, we had very little automation, but against that, we were working in a very different environment. I mean, chemists were doing handcrafted bespoke syntheses, so they weren't making many compounds. All analytical support was central, so you had experts running the samples and getting the data out. But the result of that was having quite a lot of analysts per chemist. So I think the ratio was probably about 8 to 1. Don't quote me on that, but I think it was about 8 chemists to 1 analyst was about the ratio. I suspect the ratio is at least twice that now. There's twice the number of chemists, and the chemists themselves are far more productive. They're doing things like high-throughput chemistry, and a lot of the analyses are not done by experts anymore. The systems that have been put in place, again, through automation, allow non-experts to get this data back. So things have changed, and these changes tend to demand automation because the sheer volume of information which is getting generated, or data which is being generated, requires some automation to allow people to function correctly. So I think those are probably the biggest drivers for automation, quite apart from the side benefits that you get from it as well.
Yeah, and in fact, I mean, I think I was thinking when you were talking about the ratio, I was thinking about what's the worst ratio that I probably know about, because I've been around the industry a little bit. I'm not going to mention the organization, but I think it's in the region of 40 to 1. So actually 5 times that 8 to 1 that you were mentioning. And let's say that organization, or the analysts at that organization, were one of the very first people to engage us on automation solutions for absolutely evident reasons, right? Which is probably they couldn't cope with their workload at all otherwise. And I guess the automation in the analytical lab, it a little bit flows through from the automation in other parts of the laboratory, right? We're able to do many more experiments, synthesis, for example, if you're talking chemistry, much faster in parallel, but then the analysis have to be run and somebody has to interpret them, or they have to be interpreted somehow, not necessarily by somebody. So still thinking on the analytical automation side of things, what that does look like? What are the main areas? How is this being done in the industry? What's the landscape for analytical automation in the industry today, John?
Well, I suppose there are lots of different types of automation, and the one that most people tend to think of is robots and automation of sample handling and instrument control. And then there's the automation of the data processing that comes out of it. Then there will be automation of the information extraction. Once you've got the data, how do you get information out of it? And then lastly, how do you automate the decision-making process? So those are sort of loosely the areas that I would probably mention for analytical automation. And instrument vendors have actually done a pretty good job of the first bit. So automating their instruments, having high capacity auto samplers and software to run them. That's generally been done pretty well by the instrument vendors. Even maybe the first step of the processing has been done well, so having automated processing as part of that. But data processing and instrument control are just part of the process.
Yes, and in fact, I'm very interested, particularly in the last couple that you mentioned, because I do agree that people tend to think about robots in a way when you talk automation, first of all, right? And in fact, I think We have in our website, there are a series of articles about automation, and the first one I think is titled Rise of the Robots. So we're kind of contributing to that a little bit. But obviously a robot is not necessarily only understood in the wide sense. It's not just a piece of metal that performs a specific task. It can be a piece of code that does something, right? And from my perspective, I think the last two you mentioned, information extraction and decision making, are particularly interesting, So
Yeah,
maybe you can comment a little bit on that.
yeah. I mean, obviously, companies like Mestrelab step in at this point because Mestrelab have built up a lot of skills and knowledge in this space. And obviously, information extraction isn't just simple processing, trying to maybe extract multiplets out of an NMR spectrum or integrals out of a chromatogram. These are things that require quite complex algorithms to get the best out of them. And of course, you can't make decisions unless you've managed to extract the right information from your data sets. So each of these things are linked. If you do one badly, then the next bit will be done badly. It's a follow-on. So you need high quality information extraction, and that will allow you to create expert systems that can make the decisions for you, or alternatively, at least summarize it in such a way that either an expert or a non-expert can understand the data and the information about it and then make the decision. But obviously, we'd like to push it all the way through to decision making if we can. That's really where we'd like to get to.
Well, I think that's of course the ultimate objective, but you're right that sometimes we also have to think and be realistic about what the system can achieve and where the value is, and maybe presenting the right information to still a human decision maker or allowing review by exception, etc., can already be very valuable, right? And maybe by always expecting the maximum from the automation, we sometimes expect too much, and we may be disappointed by the results. So you're referring a little bit now to the area of focus of Mestrelab from the automation perspective, and that presenting the information to the expert or non-expert. Would you say at the moment that's the limit of what Mestrelab can offer to the market?
Yeah, no, of course not. No, I mean, Mestrelab has got a lot of automation tools which allow you to wire up these things in different ways. I think that's one of the strengths that the Mestrelab have currently, is that the flexibility of the automation in the Mestrelab product line allows automation to be used in all sorts of different ways. It's not just about that. And using it in the appropriate place is what makes automation work. It's a lot of single pieces which join together to make that overall workflow. So yeah, Mestrelab's got a lot to offer in this space beyond just the information extraction.
Sure. And so, John, you've obviously automated within the Mestrelab environment, certainly in the last year, probably at some points before that as well. And you have automated elsewhere. But, what is the common thread? How do you go about automating a process? How do you think about that? And what is the process to automate a process, if you forgive the redundancy?
So, as I mentioned earlier, maybe taking a step back from that process and seeing where it fits into the broader scope, because the overall big process is probably evolved to support the existing inefficient manual processes. And when you start automating one part of the process, you'll probably break other bits because you're just doing a small subset. So you have to look at the overall process. And then you have to try and decide what you're trying to achieve by it. And then when you've done that, you then standardize your inputs and outputs. And this is really, really important. And a lot of people don't do this, and they allow for a whole range of different inputs. And variability in inputs and outputs is a real killer of automation. So, for example, if you've got chemists submitting things in a variety of containers like round bottom flasks or HPLC vials, yeah, sure, a human can handle that quite well. We're very, very adaptable, but automation will struggle with that. And if you can get the chemist to submit in the same sort of container, hey, you've just made life an awful lot easier for everyone.
So would you say that automation actually is inflexible? I mean, it maybe takes away a little bit of the fun that's inherent to entropy and chaos, but it's would you define it as inflexible?
Yeah, to some degree it is. I mean, it's a trade-off. But that said, it doesn't mean to say it can't be changed. So a well-designed automation can be modified to allow for changes in the overall process, or even changes to your local process. And again, this is where it's really important to define your inputs and outputs, because once you've done that, you can modify part of it. And as long as you satisfy the inputs and outputs, then you can change the middle bit. So it's not totally inflexible. It just means that you have to have some rules about how things are submitted and what data sets you need to have submitted to it. But you should always do it on the understanding that everything changes. Nothing ever stays the same.
Yeah, so the chaos is still there, and we can still have the fun, which is great. Which is great to hear. John, I'm maybe there is often this misconception, which I guess goes back all the way to the Luddites, that automation will actually destroy jobs, right? And this has never happened. It's fascinating how we continue to think that, even though the observation is that the more automation tools that we have, the harder we all seem to be working. So, at least myself, that's for sure. I would love somebody to fully automate me so I could spend my time having daiquiris in the Bahamas, but that hasn't happened as yet. But would you say, so this is the main thing that we focus on, right? Automation, in a way, frees up people time, I guess, and not really to destroy the job, and not need, well, it happens in some very specific areas, but in general, I think of it more as freeing people time to do more high value added things. But does it allow you to achieve other things in addition to that?
Yeah, I mean, so you make a really good point there, is that actually automation allows us to do some of the other things that we needed to do, but we've never had the time to do. And so I never see it. I never see it as a threat. I mean, it can be used that way. People can use it to reduce staff numbers, but the reality is normally those staff have got so much to do, so much important stuff to do, that they can't get round to. Automation helps with that. But actually, one of the nice byproducts, which people maybe don't necessarily think about, is that automation gets you to generate data sets which are standardized, and if you've designed it well, they will be decorated with potentially very rich metadata, and this is a valuable thing to do.
And why is it? What's the value in that, John? Why is it valuable? What would you say are the main benefits of having those enriched, standardized data sets? This is a leading question because I totally agree with you, but it's great. It's great to outline what the value is.
Yeah. I mean, as a minimum, it allows you to aggregate data and mine it for insights. Because if you know that you've got good metadata describing that data, you're comparing apples with apples, not apples with oranges. And so this allows you to do some very good feature extraction from the data. And it could be something complex like, and I've done quite a few of these things, training a system to predict analytical features like retention time, for example. If you've got a large enough set of data with chemical structures associated with it, you can use that in a deep learning model to allow you to predict retention time, which is a useful thing to do. Or you can use the really simple case. You can just say, well, just tell me how my instruments are being used during the day, so I can see whether they're running at capacity, how long the queues are, what times of day people use them. I mean, even simple things like that is quite useful for. Perhaps one of the best ones that I've come across is most LCMS systems run a system suitability sometime during the day, probably first thing in the morning, maybe a couple of times during the day. If you can grab all that data and aggregate it, all of a sudden you can start seeing how the performance of your instrument is changing over time. You can see whether it's going to be needing a service at some point, because you can extrapolate out to look at signal to noise or things like that. Or, for example, you can actually use it to alert people and say, this instrument, even though it's meant to be set up the same as another instrument, is giving you very different data. And now you can start aggregating that and letting people know instruments are not set up the way they're meant to. I can give an exact example of that. We had two systems supposedly identical, and they were giving totally different results. And you could see that on the plots we had of them. And it turns out someone had the wrong path length flow cell in one of them. And the only way we knew that was because we were getting this standardized data that allowed us to do that. And it was very obvious. You just looked at it and you go, hey, there's something wrong with that one. So yeah, automated data is or standardized data sets, richly decorated. That's a huge benefit, and perhaps maybe even the biggest benefit. I don't know. It's a close run thing, but yeah, I would say so.
And obviously you've talked about some of the applications and some of the very obvious values, because that example with the system suitability and those two instruments, that let's call it wrong instrument, will have continued to be used for God knows how long if you hadn't done that analysis. But are there other sorts of automation that we haven't covered so far, we haven't mentioned or stopped at?
There's one that's sort of implicit, but maybe it should be explicit, and that's the automation of data capture. If you want to be able to do something with the data, you need to capture it automatically. I know I've experienced systems that relied on manual data capture. So someone will have to decide they want to store this data long term. And the problem with that is sometimes people forget and they don't store it long term, or they decide it's not worth it. It was an intermediate, or it was something that they didn't think was that important. And because it takes an effort to store it, they don't bother storing it. But that then, it means that you're going to be missing out on a big chunk of your data, and you're losing that information, and it costs money to acquire it. So you might as well try and gather it. So yeah, automated data capture is absolutely a key thing that I believe that adds value to your lab, or gets the most value out of your lab.
And you've mentioned the fact that it costs money to acquire the data, but what about to keep all that data? If you're really going to be capturing everything everything that you're acquiring, do you think there is that cost is a consideration as the storage, the cost of the storage of all that data?
No, so data storage is cheap, and it's getting cheaper every day. I mean, it has been for the last. Pretty much ever since I started doing this stuff, it's got cheaper and cheaper and cheaper. And if you look at the cost of storing the data compared with the cost of acquiring it, we're talking about fractions of a penny for storing it, as opposed to many pounds or dollars for actually generating the data in the first place. So in the overall scheme of things, it's not an expensive thing. However, you do need to manage it. And this again goes down to, you have to have the rich metadata. So it allows you to be able to find the data that you want amongst all that huge amount of data that you've stored. That could be a big cost if you haven't, captured that metadata. But if you capture it automatically, it's actually zero cost to the person who's generating the data. It just happens, and they don't have to do anything about it. So I think overall you actually save money by doing that.
Okay, and John, what would you comment on the concept of all data, which brackets is no longer needed brackets? Because there is often this concept, right, of I'll keep data for this for the certain period of time, and I will throw away everything else, which maybe is a throwback from the time when storing was a lot more expensive, right? But do you have thoughts on that?
Yeah, I mean, and sometimes there are legal constraints where you have to get rid of data. And again, it's very important you can find that data to be able to delete it. But if you don't need to throw it away, personally, I would just say keep it, because you never know when it's going to come in handy. And once you've thrown it away, you're never going to be able to get it back. But if you do need to throw it away for whatever reason, like your disks are running out of space and you can't afford to buy new ones, which it could be possible. Again, if you've got the right metadata, data lifecycle management is an automated process as well. So you don't have to worry about it. You can say once it's got over a certain age, unless it's got a litigation hold on it, then you would then automatically delete it or flag it for deletion, and then someone would do that. But I have to say I've never regretted keeping data, and I've often regretted throwing it away. So keep it if you can.
Okay, so I may give you a nickname and call you Diogenes from now on, but I do agree with you, and especially I think with things now like machine learning, etc. There is often I think it's sensible to keep data even when it's not clear what to do with it, because the applications and the value may become apparent later, right? But like you very well say, if you threw the data away, then by the time you understand how it might have been valuable, you no longer have it and you can get it back. Yeah. So I will say the risk managed, or its your position, is to keep as much data as possible, obviously well organized and with the rich metadata, as you well say, because we never know what new technologies are going to allow us to do with it, right? So I think, very interesting. We covered a lot around automation, and I'm sold on it, and obviously some of the some of the considerations that often worry people maybe are not there. So let's say, great, we are sold, we want to automate. What are the main challenges when you want to automate a system? What obviously you've done it a lot. So how would you summarize the challenges that we're likely to find?
Yeah, I mean there are challenges. Maybe one that's not considered all straight up is people. Change is often difficult for people. People don't tend to like change. So really, you probably have to have a change management effort as part as probably just as important as designing the good automation in the first place, so that people are bought into it. And also you have to be aware of what impact that automation is going to have. So it may make life easier for a bunch of people, but one or two people might be slightly disadvantaged. And whilst the overall business benefits, those individuals are probably going to feel a little bit upset that they've got more work to do just to support this. So when I've had situations like that, I spent a lot of time working with those people so they understand that their contribution is making a bigger impact to the organization. But also I try to sweeten the bitter pill a little bit by maybe using some of my resource to make their lives easier, maybe in a slightly different way, so that they feel that they're getting something out of it as well. But yeah, managing the people's expectations is a key one, and often overlooked. Actually, a lot of people go for the technical, but the people side of it, the soft side of it, is actually just as important, maybe more important. What other things? Other systems. So we don't live in a vacuum. We generally have, or if we're working for a big organization, you have lots and lots of informatics systems, and you're trying to embed this within that infrastructure. So getting your automation system to work with the constraints around that can be quite challenging. This is where you need good flexible automation to allow you to do that.
And as a vendor, sorry, and you do want to make it flexible, because otherwise the problem is you are making a bespoke system every time you find a new customer environment, right? So yes, from Mestrelab, we very much think about that perspective, trying to, I guess we're trying to make a master key rather than a key for each customer log. Let's put it that way. But you're right that the best automation product, if it is not adaptable enough to the environment where it is going to be deployed, is gonna follow. So any others or the challenges?
Well, I mean, you mentioned one of the things that Mestrelab brings. The other one is a lot of people design systems around a particular instrument vendor because they know how the data comes from that instrument, and they know how to control that instrument as part of that automation process. And so now, then you get locked into a particular hardware vendor, and that can be quite disruptive because it's so hard to come away from it. So, Mestrelab, because of its independence, supporting many different vendor formats out of the box, that means that you can design your automation system to be vendor independent, and that gives the customer far more freedom to choose the best of breed at the time when they're buying the instrument, not just say, oh, I bought it from vendor X and I'm always going to have to buy from vendor X going forward. So this is actually a key enabler that Mestrelab offers, the fact that it can be vendor independent. And probably the other one is the IT support. So companies' IT departments are not really always snowed under with the requests. They've got limitless amounts of demands on their time, and they tend to devote their time to the large systems that everyone uses. So sometimes the analytical systems may feature quite low on their priority list. So, and also they may not have the analytical domain knowledge either, which is really important when you're setting up systems like this. But if you can use off-the-shelf products which are configured for a specific workflow, or can be tweaked using scripts or something like that, then actually that means that you don't necessarily have to involve the IT department to the same level. They probably want to be informed, but if they don't have to work too hard on it, then it means that that's a really useful thing to do. And of course, Mestrelab offer that in their automation scripting. And I know personally, as a customer, I've used that scripting help before because I didn't want to learn the Mestrelab scripting stuff. Some people do, and they get on with it very happily. And me, I was just too busy, and I relied on consultancy from Mestrelab to help me to deliver what I needed to deliver. And that was a great thing because it meant I was able to deliver a system without having to go on the waiting list for our IT support, which could have been some way down the line. So yeah, those are probably the big things which I found as being challenges.
And you obviously spoke about systems that the large systems that IT will be focused on. So what kind of systems are you referring to when you talk about those?
Well, probably the biggest one is the electronic lab notebook, because that tends to be the source and sink of the data. So it's where your requests come from and where your information has to go back to. So being able to interface to those is a very important thing. But there's all sorts of other systems like security and authorization systems, data repositories, LIMS, effort tracking, instrument inventories and service. The list goes on, and they all probably impinge on your automation to some degree, some less, some more, but that's what you've got to be able to have the flexibility to be able to interface with. So yeah, it's a challenge, but as long as you've got the tools to do that, maybe you can get away with it.
And how do you get around it? And can you maybe speak a little bit more about that, or give a little bit more color?
So an ELN is a good example. When you've designed a system to work with a particular ELN, and then the company then decides you're going to have a different ELN, if you have lots of hooks into the original ELN and you then have to try and rewire your system to have different hooks into the new ELN, that can be really disruptive. So the way we tend to get around that is to write wrappers. So you effectively insulate yourself from the data system, whether it be an ELN or something else. And so if that changes in the future, most of your automation stays intact. The only thing you have to change is the wrapper, and that allows you to isolate yourself to some degree from changes that happen around you. So creating these wrappers is a very important part of the design. It's probably, maybe shouldn't go into any great depth on that now, but that's, as a general design criterion, that's a really good way of doing it to make sure you are independent of these as much as you can be.
Yeah, in fact, I think that's very good practice, and I totally agree. And I hate projects. Sometimes we engage in projects with customers in which we are integrating to one specific system. I'm always much more comfortable when my team is exposed to at least two customer environments with two different systems for the same use case, because that prevents you or stops you from being able to take shortcuts and, like you say, putting hooks into the system just to get a quick result, but then you are basically dead as soon as that system changes, right? It may be that the customer changes the whole system, or it may be just that some of the interfaces and hooking points change, and you already have a problem, right? Yeah. So I totally agree. So John, obviously we're at a very interesting moment for automation. It's very topical. Where do you see it going next? What's next for automation?
Well, it's very, very trendy. Artificial intelligence, machine learning, those are, very high on people's priority lists. I've seen enough of these things to understand the hype curve. And I think they've gone over the peak of the hype curve. And now we're getting some real use cases coming through, which are valuable. But AI or machine learning both require the same thing. They require high quality training sets. And you can generate high quality training sets by using automation to generate those standardized data sets with all of that really rich metadata. Those are the things which make AI and ML really sing. And if you don't do that, that can be it can be hard to go on to the next stage. We're going from that pyramid, the data, information, knowledge, wisdom. I think it's enlightenment is the one above that.
Right.
And we're trying to use these tools to do that, but each one is dependent on the previous one. So unless you've got some good stuff underpinning it, you're going to end up with a bad model.
Mm-hmm. And what do you mean exactly by high quality data sets, which I think are fundamental to this, but how would you define it?
So data is just data at the end of the day. The data in itself is not inherently high quality or low quality, but the information that you have about the data, that can make it high quality or not. So you might say, I'm only interested in final compounds, not intermediates. Well, yeah, but the intermediates still contain valuable knowledge or information that you can extract. So what you really want to be able to do is say, I only want to compare final products, in which case, as long as you've got that identified in your metadata, you can filter accordingly. Alternatively, you might learn something by comparing final compound data sets and intermediate data sets. You may see that, I don't know, impurity levels are much higher at certain levels of the process, and maybe that helps you learn something about your process. So there are a lot of things you can get with it, but high quality generally means decorated with consistent, good metadata, as wide as possible. And sometimes your metadata can almost be as big as your data for some data sets, but the more you've got, the more you can start doing this stuff.
Mm-hmm. And of course, doing this stuff is very interesting. And what's your feeling? Because we often, it's a little bit of the science fiction conundrum, right? We have an idea as to how something may happen. We get a huge hype, and then it never happens. And then at some point, it suddenly happens when nobody's looking anymore, and it catches everybody by surprise, even though it's been announced for 20 or 30 years, maybe even sometimes in advance. So when is this big step change happening, John? And when in your view, and from the perspective of the laboratory, of course, is this AI, etc., coming here?
Well, I think it's happening already. We're seeing these things happen already. People are using deep learning models to try to extract more information. I think it will continue to accelerate. Probably in the analytical lab, we're a little bit further behind than some other areas, but it's going to accelerate. I think it will accelerate rapidly over the next few years. The thing is that even though the technology is moving forward, you're still basing it on data sets which have been generated over the last 5, 10, 20 years. So the winners will be the companies who've invested in automation and created those really well-defined and curated data sets. You can't just start on day one and hope that you're going to create those things. You've got to have a body of data that's been acquired to these standards, and those companies will really benefit. They will be right at the top of that pyramid, and maybe they'll be in a state of enlightenment as opposed to being confused about it.
And yes, I'm actually right now reading a book called Enlightenment Now. So it's funny which, by the way, I recommend, by Steven Pinker. And it's funny that we've ended up on the subject of enlightenment. I think this is what we have time for today. Very interesting, John. And I think maybe the main takeaway message that I take from our discussion is the high quality curated data sets enriched by metadata. And, don't start building your data set when you have the tools to do something with it. Start well in advance, and the tools will ultimately come and allow you to get the value from it. So, it's very interesting talking to you, and thank you very much for your insights. This has been episode 3 of the MestreCast, and I just would like to remind the audience that you can find all the MestreCast episodes, if you missed the previous ones, in iVoox, Apple Podcast, and Spotify. And of course, you can follow us on our social media channels, LinkedIn, X, Instagram, Facebook, where you will see announcements of future episodes as well as links to catch up with the previous ones. So, John, thank you very much for your time. It's been really interesting and great fun. And since we're recording this on a Friday afternoon, have a great weekend.
Thanks very much, Santi. You too.
Thank you.